Hello, I'm Dr. Zane Raudenbush. I'm a turfgrass scientist at Ohio State University. I'd like to welcome you out to our research green at Hawks Nest Golf Course in Creston, Ohio. I'd also like to thank my friend Mr. Kevin Ross for inviting me to be a part of this Professor Talk series. And what I want to talk to you today is about a plant that I've studied now for approximately 8 years, which is silvery-thread moss. Silvery-thread moss is a very difficult to control plant once it gets itself established in putting greens. And that's really why I want to start this story, is thinking about that invasion process. Mosses were thought to be this really slow growing organism that only infested, saturated soils that were heavy in shade and under-fertilized, and I can tell you that that is not the case. I've seen silvery thread moss infest really healthy putting greens where superintendents are using what we would consider to be the best cultural practices. A few things that I focus on with superintendents when trying to develop a moss control program, a comprehensive moss control program, is I first want to understand what are the irrigation practices being used on the property. This plant cannot survive without water. It needs water to be actively photosynthesizing and growing. So anything that you can do as a superintendent to limit the frequency with which water is put onto the putting surface is going to be advantageous. I'm not so much concerned about the quantity. I'm more concerned about the frequency. This plant's water use requirement is very little. It uses very little water, but it has no ability to extract that from the soil surface. So through our irrigation practices, we're just constantly supplying these little bits of water that the plant needs to be actively growing within the turfgrass surface. The second thing that I like to know is, what are your fertilization practices? I found through my research and through others' research that silvery thread moss loves soluble nitrogen. If you are a spoon feeder, a sprayer of a lot of your nitrogen, you'll see that this plant is soaking up all that nitrogen, and it really helps it to grow more vigorously. The third thing I like to ask superintendents about is the age of the infestation, which they may or may not have any information about. If you inherited this problem, you may not have an idea of when it actually came in. But what you can do as a superintendent is just to take a cross section of a moss colony, and when you look at it in the soil profile, the deeper that moss shoots and rhizoid extend into the soil surface, the longer that colony has been there. I call it like rings on a tree, that the deeper that's going, the older that infestation is. And that's relevant because from what I have observed, the older the infestations, the much more difficult they are going to be to control. So the longer that you allow this to perpetuate in the putting surface and do nothing about it, the more uphill battle you're going to fight to actually get it eliminated. I wanted to discuss with you this recently funded USGA research project where we're looking at moss control in putting greens. The primary objective of this project actually is to identify a combination of cultural and chemical control strategies that are primarily geared towards heavily infested putting greens. So, there's kind of two pieces of infestation: the early initial phases of when moss begins to infest the putting green, and then we have existing infestations that can become large in size. And this study is really tailored towards an infestation that's been around for several years that is continuing to grow and grow within the putting green. We need to give superintendents a tool to try and eliminate and reduce the size of those infestations quickly. The most commonly used tool is to use frequent applications of the herbicide Quicksilver. And Quicksilver is effective at injuring the moss, but it does not eliminate it from the putting surface. So you think about applying a herbicide to control a dandelion, it injures the dandelion leaves. Eventually that plant carcass breaks down and the desirable plants fill in that void where the weed was. But the problem with moss is it's very resistant to decay. And so we have this situation where we apply a herbicide, it temporarily injures the moss, but the plants remain in the canopy and the desirable species cannot fill back in. And so within this study, this is what we would call a 2x4 factorial. We basically are looking at 4 treatments. We have an untreated control. We're applying Quicksilver every 2 weeks at 3.3 fluid ounces per acre. And then we're using a drench of Dawn dish soap. And the solution is somewhat proprietary right now, but we've determined there's an ideal solution with which we drench onto these plots, and we have seen that we are able to get, as you can see in front of me, actually some really good moss control. And then our fourth treatment is looking at a drench of a solution of sodium dodecyl sulfate. Sodium dodecyl sulfate is a common surfactant It's what you find in most hand soaps, dish soaps, detergents. It's very, very common. The reason we've included the sodium dodecyl sulfate is it's very cheap, and it could provide superintendents a really cost-effective way to control moss in large areas of turf. And then we also are looking at applying cultivation to these treatments. So we have those 4 chemical control strategies with and without aerification. And the aerification is we're using the Procore 648 with 1/2-inch tines on a 2-inch spacing, and we are going to aerify pretty much the minute that these holes are healed. We're going to come out and do it again. We hope to get 3 aerification timings within the growing season this year, and we'll come back out in the spring and we're going to put out the same type of treatments. Aerification is a tool that within a moss colony, when you think about having a solid colony of moss, that if we can come in and create some voids within that moss colony, we may allow that desirable turfgrass species to fill that area. And so we're trying to create available sites for the desirable turfgrass species. One of the issues, though, with aerification from the traditional sense is we often do it only in the spring and the fall. And so the frequency with which it's done may not introduce enough available sites in areas where moss is heavily infested to allow those desirable grasses to actually gain a foothold. So we're going to be quite aggressive. This study, we're going to aerify pretty much once the holes are healed. We're going to come out and aerify again. And so before the study was even started, we came out and we rated how much moss was in each plot by using a rating grid and counting whether or not moss was present or absent within each rating grid. So we have an initial count. We've put our treatments out, and then we will come back and rate every 2 weeks until probably sometime in mid to late November, depending on what the temperatures look like. We'll be able to track the progression of how moss cover changes this growing season, and then we're going to come right back out in the spring and do the same thing. In summary, I look forward to bringing you the results from this study. And so far what we're seeing, you can see these plots over here. Anything that is orange is where silvery-thread moss was. My good friend who's a bryologist at UNLV said that orange is the color of death when it comes to mosses. So we are headed in the right direction. I really want to tip my hat to the USGA and having the foresight to recognize that this is going to be a challenging problem for superintendents to manage. And that's my perspective right now, is that there simply just is not enough tools to help you get this problem under control. And so that's what this study is focused on. We're hoping to provide you with some more tools to effectively manage an active silvery-thread moss infestation. And I'm really excited to bring you the results here, hopefully within the next few months.